Hey guys, so I am going to go over some notes and example problems that will help you do the balancing and mole ratio assignment. Today's assignment is going to be very similar to the one we did yesterday, where we are using our balanced chemical equations to convert from one type of molecule, one mole of a molecule, into another. However, yesterday's assignment, things were already balanced for you. Today's things will not be balanced for you. So our first step in all of these is going to be to balance the equation. So I'm going to go ahead and write out an equation here. So I have HCl, and I've got some NaOH, and that will yield some NaCl and some H2O. Okay, so here's my equation. And before I even do anything else, I'm going to make sure that this equation is balanced. Okay, so on the left side of my arrow, I've got some H, some Cl, some Na, and some O. And on the right, I've got some H, some Cl, some Na, and some O. Okay? So on the left-hand side, I have one hydrogen here, and I have one hydrogen here, which means I have a total of 2. I have one Cl, I have one Na, and I have one O. Okay, over here, I have 2 hydrogens right here, 1, 2. I have one Cl, I have one Na, and I have one O. So good news, this equation is already balanced. I don't have to worry about that. Okay? So the second step that I'm going to do, and what you'll be asked to do on question number 1, is to write out what this means. Okay? So what this means is that for every 1 mole of HCl and every 1 mole of NaOH, I'm going to get 1 mole of my products here, okay? And again, if there's no number in front here, we just assume that it's automatically a 1, okay? So 1 mole HCl and 1 mole NaOH makes 1 mole of NaCl and 1 mole of H2O, okay? So this is our conversion factor for doing any problems here, okay? So what if I have 4.75 moles of NaOH, and I want to find out how much HCl. Okay, so this is our problem. All right, so I have my conversion factor, which is basically just 1, 1, 1, 1, 1. Okay, and I made sure that was balanced. I wrote it out just to double check myself. And so here is my problem. Okay, so I'm going to draw my T-chart. Okay, and up here, I'm going to start with the number that I'm given in the problem, which in this case is this value right here. So I have 4.75 moles of NaOH. And again, I'm over-labeling because these are about to get pretty complicated, and I want to make sure that, I'm tracking all of my units appropriately. So I have 4.75 moles of NaOH. Okay, now if I look back at my balanced chemical equation, I know, because all of these are 1s, okay, that I have 1 mole of NaOH here. So if I have moles of NaOH here, I gotta have moles of NaOH here. And using my equation, I know that it is 1. Okay, now I'm trying to get to moles of HCl. Okay, and again, looking up here, I have 1 mole of HCl. Okay, so I'm going to take this value and multiply it by this, which is just going to be 4.75 moles of HCl. Okay, so that's my answer here. All right, let's do one that's a little more challenging, that we have to actually maybe balance some on. I'm going to tear this out. Okay, sorry. All right, so let's get an equation. I have some N2 and some H2, and that is going to yield NH3. Okay, so first step, I'm going to balance my equation. All right, so I have some N and some H on either side. So over here, I have 2 nitrogens, and I have 2 hydrogens. And then over here, I have 1 nitrogen and 3 hydrogens. Okay, now I always do my hydrogens last because they're usually the ones that are the most like jumbled up with other molecules. So I do them last. It's just easier that way. And a lot of times if you do them last, they will mathematically work themselves out. So I'm going to start with my nitrogens. Okay, if I have 2 nitrogens over here, I need to make there be 2 nitrogens over here. So the best way to do that is to just slap a 2 right in front of that whole entire thing. Okay, so that of course changes the amount of nitrogens that I have. But because this is stuck to this hydrogen here, putting a 2 here is going to change the amount of hydrogens I have to the right of my yield sign. Okay, so if I have 3 and I double that, now I have 6. All right, so my nitrogens match. Now I have to mess with my hydrogens. So I have 6 over here and 2 over here. And this one's pretty easy because it's just a hydrogen on its own. So if I have H2 and I need to be 6, I can put a 3 in front. That makes that 6, and now that equation is balanced. Okay, so then I'm going to write it out where I have 1 mole of N2 and 3 moles of H2, and that will yield or make 2 moles of NH3. Okay, and again, remember from yesterday, once we have this equation balanced, we're not going to pick it apart, okay? So, let's say, here's our question. If I have, let's do 34.8 moles of NH3. Okay, and I want to find, let's say I want to find moles of H2. Okay, so I'm going to draw my T-chart. Okay, up here in the top left is the value that I know from my problem, which in this case is 38.4 moles of NH3, or 34.8, excuse me, moles of NH3. If I have moles of NH3 up here, I have to have moles of NH3 down here. And using my balanced chemical equation, I know that my value is going to be 2. So I have 2 moles of NH3 in my balanced equation. Okay. Now I'm trying to get to moles of H2, which is what I'm going to put up here. And then using my balanced equation, my value is going to be 3. Okay. So I'm going to put that in my calculator. I'm going to say 34.8 times 3, and I'm going to hit equals, and then I'm going to divide it by 2 and get 52.2 moles of H2. And that is my answer. Okay, let's do one more. This one's going to be really challenging to balance, but sometimes doing difficult things are good for you. So let's say that our question is I have 34.8 moles of S8, sulfur octate or something like that. Okay, and I want to know how much CS2 do I need? Okay, so here's my unbalanced equation. I have CH4 plus S8 yields CS2 and H2S. Okay, so this one's a little more complicated, mostly just because we have this 8 right there, so that's going to make this bigger. Okay, so let's draw our little line. I've got some C's, some H's, and some S's. Okay, so, excuse me, on the left of the line, I have 1 carbon, I have 4 hydrogens, and I have 8 sulfurs. And then over here, I have 1 carbon, I have 2 hydrogens, and I have 1, 2, 3 sulfurs. Okay, so, oh boy, these numbers are already uncomfortable for me. Okay, so 8 and 3. There's nothing I can do to make those numbers be really nice. So what I'm going to do is kind of ignore them for right now. Okay, and maybe by working with my hydrogens, it'll give me some more insight as to what I need to do here. Okay, so I know I said I like to leave the hydrogens for last, but sometimes you just got to do it this way. All right, so I have 4 hydrogens over here, and I have 2 on this side. So I can easily make that be 4 by just adding a 2 in front right there. Okay, that also changes my value of S, so I have 2 S's here, and I have 2 S's there now. So this is now a 4. Okay, now this is great because while those match, this doesn't, but 4 is a lot nicer to work with than 3. Okay, so what I'm going to do, because I know that I need to at least double the amount of sulfurs on this side, I'm just going to go ahead and double all my sulfurs. Okay, so if I have 2 sulfurs right here, I want to make there be 4 right here. And the best way to do that is to stick a 2 in front. And if I have 2 sulfurs here, I want to make there be 4 sulfurs. So I'm going to stick a 4 in front. Okay, now that changes everything, but hopefully it makes it a little easier to balance this crazy equation. So now I have 2 carbons. Now I've got 4, 8 sulfurs, which that's pretty nice. And then I've got 8 hydrogens. Okay, so if we look back over here, my sulfurs now match, which is great because that was the one that was the biggest pain. But nothing else does, which is annoying. So if I have 1 carbon over here and I need it to be 2, I'm just going to stick a 2 in front of there and see where that gets us. So that changes my carbons. It also changes my hydrogens to 8, and 2, 8, 8, I am now balanced, which is awesome. Okay, so my equation says, or my question says, I've got 38.4 or 34.8 moles of this S8. How much of this CS2 will I make? Okay, now I have my balanced equation, which is my conversion factor. I'm going to go ahead and draw my T-chart. Up here in the top left, I'm given 34.8 moles of S8. I know that if I have moles of S8 up here, I have to have moles of S8 down here. And using my balanced equation, I know that my value is 1. Okay, now I'm trying to get to CS2, which if I use my balanced equation, I know now that there are 2 moles of CS2 for every 1 mole of this. Okay, so I'm going to go ahead and put that in my calculator. 34.8 times 2 gets me 69.6 moles of CS2. Okay, that was not how you write that. There we go. Okay, so one more thing I want to talk about briefly before I turn you loose on this assignment is, in this assignment, question number 2 says, for each of the following unbalanced chemical equations, which first of all you're going to have to balance them, calculate how many moles of the product would be formed if we had this many moles of the reactant. Okay, so remember that anything before your arrow sign, oops, these are your reactants. Okay, what that means is that we put these things in a bucket or in a beaker and let them do a reaction, and they produced the product. Okay, so for example, on the first question of this assignment, it says blah 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 blah, for your product would be formed with your reactant. So this is our product that this is our reactant that we're talking about. So we're going to have 0.125 moles of this reactant, and we're looking for how much of this product it will make. Okay, so here's our reactant. We're looking for the product. Here's your reactant. You're looking for the product. Okay, so I didn't want that to trip you up at all. But that is it for our notes and examples on this worksheet. Let us know if you need anything or if you have any questions, and I will see you guys later. Goodbye.